Right, welcome everybody to our systematic reviews workshop today. We're happy to have you here. My name is Daisy de la Rosa. I'm an Information and Instruction Services Librarian at the FIU Medical Library, and I'm joined today by Ramses Marsili, one of our reference and instruction librarians at the FIU Libraries, and our Health Sciences Librarian, Joanna Fernandez, also from the FIU Libraries. So this is part of our Work Smart Library workshops. We've already had a few this semester. As you can see there, we had one about AI tools for library research, a library research refresher. And we have a few more coming up in the semester. So we have on citation management in a couple weeks. So 3 different softwares for you to explore, RefWorks, EndNote, and Zotero. At the end of the month, we'll have one on where should I publish my research. And there is a research retreat for upper division and graduate students that's in person and online. So the QR code is on the slide here for you to register. There's still time. And we do offer these every semester. So if you can't make it to one of these, the recordings are available. But of course, you can always join us in the spring as well. So we want to just start with a quick poll just to figure out what brings you to today's session. If you've worked on systematic reviews before, but maybe you're just looking for a refresher, more information, maybe you are going to work on one and you want to learn more before you embark on that project. If you've heard of systematic reviews, but you're not sure what they are, or you haven't heard about them, but the session sounded interesting. So you can use a QR code to join there. I'll try to put the link in the chat too if it makes it easier to answer the poll. Okay, great. Okay, cool. Let's give it like 10 more seconds. It looks like, most people on the call have worked on systematic reviews before, but always appreciate a refresher or more information. All right. Okay, great. Thank you for participating. So we have, experienced folks on the call, which is nice, and will provide some good conversation. All right. Okay, so a little bit of housekeeping. We'll pause for Q&A throughout the session. Feel free to put your questions into the chat box. You don't have to wait for us to pause for that for questions and answers. And then the recording of this session will be available on the FIU Libraries and the Medical Library YouTube channels. So our objectives for our session today, we're going to define what a systematic review is, recognize their characteristics, and understand their importance to evidence-based practice. Know what to consider before embarking on a systematic review project, because they are long-term projects that require a lot of moving parts. So there's a lot of things to consider before deciding to do one of these types of evidence syntheses. We're going to talk about different standards and guidelines that are available to help you not only conduct the systematic reviews, but also report what you did. We will show you a basic overview of the entire process, but we're going to focus a little bit more on the search part. We are librarians. Our expertise is searching, and searching is a big part of what informs a systematic review. So we will spend a little bit more time on identifying main concepts from a research question and describe what exhaustive searching looks like, which is what is required for systematic reviews. And then for each part of the process, we'll review resources that can help you every step of the way. So what is a systematic review? So here we see a puzzle of a cute elephant. So sometimes systematic reviews are compared to puzzles where each piece is a study answering a specific question. And then the process of bringing those pieces together and then the final picture that you see is a systematic review process, right? So the systematic review is bringing in all the relevant studies that help answer a question. And at the end of it, you have the big picture of what's actually going on for that particular question or topic. So here we have a definition from Cochrane. Cochrane is one of the authoritative organizations that develop systematic reviews and provide guidance. So their definition is that a systematic review attempts to identify, so find, appraise, right, evaluate, and synthesize, bring together all the empirical evidence that meets pre-specified eligibility criteria. So we'll see that theme come up again and again. To answer a specific research question, researchers conduct systematic reviews, use explicit systematic methods that are selected with a view aimed at minimizing bias to produce more reliable findings to inform decision-making. So here on the right, we have a GIF from Cochrane showing you the process, right, where that magnet is pulling in those relevant studies. And then it puts it through that little filter, which is the systematic review process. And then at the end, you see the forest plot, which is what's usually used in those meta-analyses. So characteristics, according to Cochrane, of a systematic review, you have a clearly stated set of objectives with predefined eligibility criteria for study. So the studies you plan to include, you have to decide what is their eligibility criteria before you even start the project. It has an explicit reproducible methodology, which means that everything you've reported, someone should be able to follow it and get the same results. It has a systematic search that attempts to identify all the studies that would meet the eligibility criteria. It has an assessment of the validity of the findings of the included studies, for example, through the assessment of risk of bias, and it provides a systematic presentation and synthesis of the characteristics and findings of each of the included studies that you have found. So we also wanted to include a definition from the Campbell collaboration, who provides guidance for systematic reviews for the social sciences. Their definition is very similar. A systematic review uses transparent procedures to find, evaluate, and synthesize the results of relevant research. Procedures are explicitly defined in advance, right? So we see that pre-specified in advance to ensure that the exercise is transparent and can be followed, right? Replicated. This practice is also designed to minimize bias. Studies included in a review are screened for quality, so the findings of a large number of studies can be combined. So very similar to Cochrane. So characteristics, according to Campbell, there's clear inclusion and exclusion criteria. How did you decide what studies to include? An explicit search strategy, systematic coding and analysis of those included studies, and the meta-analysis, which we will define in a moment, when it is possible. So, and kind of to summarize those two definitions, a systematic review is a study of studies. It is a research methodology. It goes beyond just your traditional literature narrative review. The literature search that you're doing provides the pool of potential subjects, right, which again are the studies themselves. And the quality of the systematic review is dependent on the research studies that are included. That's why the appraisal is so important. That's why the search is so important, because it's going to inform the rest of the review, how comprehensive the search was. And then, of course, all the other steps, right? The appraisal aspect of it, how strong are the studies? So again, the studies you include will inform the strength of that systematic review. And then each study included should be appraised for quality by the review team. So here is a visualization of a systematic review where you have the studies, and then through the systematic review process where they meet certain criteria, where the data is extracted, it's appraised, and then at the end you have this well-constructed report, right? A puzzle in a way. And then you disseminate it, either publishing it in a journal or presenting it at a conference, for example. So we wanted to make sure that we made a distinction between systematic reviews and narrative literature reviews, because sometimes they do get confused. So on the left, we have our systematic reviews, which do require a significant amount of time, could be up to a year, maybe 18 months, whereas a literature review may take less time, maybe 2 or 3 months. A systematic review does require a team, again, to minimize that bias and to share the workload. A lit review can be completed by an individual. Now, the goals for these two types of projects are very different. The systematic review attempts to find and evaluate all the evidence that answers a specific question, whereas a lit review is trying to provide an overview of a topic. The systematic reviews are protocol driven, meaning that you are creating, before you even start the project, you're creating a plan for the systematic review, whereas a lit review, you don't have a plan a priori or in advance. The systematic reviews do have specific comprehensive search strategies, whereas the lit review, the search may not be as comprehensive. It's more iterative. It's more of the natural searching we typically do, where we put in, a couple of keywords, depending on what we see, we might change our search a little bit. Whereas a systematic review, the search strategy is systematic. It's designed, right? And then ran all on the same day. The search strategies must be reproducible, meaning you should be able to copy and paste and follow exactly what somebody did, whereas search strategies are usually not reported in lit reviews. The systematic reviews do retrieve high numbers of results typically because you are trying to be really comprehensive, cast a really wide net so that you can pretty much capture almost everything that would be answering that particular question. Literature reviews, they're not as comprehensive, so they don't retrieve as many results. The reasons for including or excluding studies are explicitly stated and decided on when you develop the protocol. The lit review, when you read one, they're not really telling you why or why not certain studies were included or excluded. So that's why we have the picking the cherries on this slide, because lit reviews are more of a cherry picking, which is more natural. It's more of an iterative approach. Whereas a systematic review, you have the haystack, right? All of, you just have a sea of results and you're trying to find that needle in the haystack, basically. And then all included studies must be assessed for the quality or risk of bias in systematic reviews. In lit reviews, they usually don't consider any differences in study methods or study qualities. So we just wanted to make sure that we knew the difference because both projects have different goals and different approaches. So why are systematic reviews important? They're often considered one of the highest levels of evidence because they help you synthesize a large number of studies that try to answer the same question. And because the methodology is, robust and comprehensive and reproducible, right? All of these things that are required. When you look at the results, you're hoping that there's minimal bias in how these results were put together, and that increases the reliability and the trustworthiness of what you're reading. So if they're done well, they're really, really useful, and they're really important for decision makers, for public health care and policies, not only health, but any type of decision making and policy. They're the foundation for clinical practice guideline for our health science folks, and they save practitioners time because they provide the best evidence available. They've basically done all of the work for you, right? They did a humongous comprehensive search, hopefully. They have screened all these articles. They've, that meet a certain criteria. They've extracted data. They've put it together. So they've saved a lot of time for practitioners, again, if they're done well. So a summary of what systematic reviews are. A systematic review is a research study. The subjects are other studies that are answering a specific research question, and the investigators are searching for, selecting, and synthesizing all the relevant evidence using clear, rigorous, and standardized methods that try to limit bias and that result in more powerful, reliable evidence. So now that we've talked what they are, is it the right fit for you, right, for your project? So you do have to consider a few things before deciding to embark on a systematic review project. So the first thing is the research question. There are many types of evidence syntheses. Systematic reviews are not the only one. So the research question is really going to help you determine what type of synthesis you should conduct. So a specific question or a set of specific questions is required for a systematic review. These are some indications of why you should do a systematic review if you're trying to uncover the international evidence, right? Trying to be more comprehensive, confirm current practice or address any variations, identify areas for future research, investigate conflicting results, or produce statements to guide decision-making. So here we have this is more of a clinical health science question, but it's very specific. Is non-steroidal anti-inflammatory therapy non-inferior to antibiotic therapy in uncomplicated urinary tract infections? So this question would be appropriate for systematic review. You're trying to find studies that have looked at this particular condition or illness and have compared these two particular interventions. But again, there are other types of reviews that may be a better fit. Here we have kind of a little bit of the spectrum, but there's a lot more of these. So scoping reviews, these are also very popular. Question is usually broader, not always, but the methodology is very similar to systematic reviews. The goal is just very different. The goal of a scoping review is to map out and identify available evidence, clarify concepts, identify gaps, and to examine how research is typically conducted for that particular question or topic. So again, you're more mapping the literature. You're not really trying to find the answer to a specific question. The umbrella review is a systematic review of systematic reviews. The question can be specific, but when a topic has already been researched a lot and there's already systematic reviews on it, the umbrella review is useful because it'll help you synthesize all the systematic reviews done for a particular question. Then you have your meta-analyses. So a meta-analysis is a systematic review, but it's the quantitative synthesis of that systematic review. So basically, it's when you can statistically combine the results from the studies. This is not always possible because some studies maybe are not alike enough to each other to be statistically combined. So you may not always be able to do a meta-analysis. Then we have the rapid review. This addresses issues that need quick decisions. Because of that, it does employ methodological shortcuts, which may introduce bias. You do have to have a valid justification for doing a rapid review. So it can't just be because, oh, I only have 3 months to work on a project. It has to be an actual reason, like, oh, we have a public health concern or we need a quick decision. And just understanding that there's going to be some flaws and biases because of those shortcuts. And then at the other side of this, right, we talked about literature reviews already. The question can be broad or specific, but ultimately the goal is to provide an overview of the topic and there's no specified methodology. So a lot of different options. It doesn't always have to be a systematic review. Another thing to consider is that systematic reviews are conducted by teams. So you do need at least 3 people to conduct a systematic review to divide work, but also so that certain tasks can be completed independently by at least 2 people to minimize errors and bias. So when you're screening studies, that each study is screened by at least 2 people independently, so they don't know what the other person decided, whether to include or not, so that they're not influenced by each other. And then the additional person can help resolve any conflicts or ties. You also want to include a variety of expertise. So someone who understands project management, who understands a systematic review methodology, of course, subject matter expertise, an information specialist or librarian like us, and to help with the search, and a statistician. And then another consideration is, do you have the time, right? And like I mentioned before, systematic reviews can take, at least 12 months. Sometimes they might be able to be done a little bit sooner than that, but typically 12 months, 18 months is what it might take, especially depending on how many results that you get, how many you have to screen, how long it takes to develop the protocol, to decide on inclusion exclusion criteria, also the availability of the team themselves. So it is a long-term project. So if you only have 3 months, then a systematic review is not going to be the right fit at this time. You have to make sure you have enough time to do this type of project in addition to having a team. So there are tools to help you decide. We do have articles that exist. There's one called Meeting the Review Family that has multiple review types that you can find the right fit for you. There's also one that helps you decide whether it's a systematic review or scoping review. There's always a lot of questions around that. So this particular article helps you navigate that. There's the what review is right for you, where you answer a couple of questions and it will recommend what is the best evidence synthesis depending on your answers. And then here, there is a flow chart from Cornell University, what type of review is right for you. That kind of also goes through a series of questions. And depending on your answers, it will recommend the type of review that best fits your availability, your needs, your type of question. So standards and guidelines, right? Let me just pause for a second and see if anyone has any questions before I continue. And I'll just pop the slides in again into the chat just in case anyone new joined that didn't have a chance to download them. Okay, so I'll keep going, and we'll check in again. All right, so now that we've talked about what systematic reviews are, we've talked about what you should consider before embarking on one. What are some standards and guidelines that are available to help you conduct a systematic review and report what you did? So conducting and reporting systematic reviews, like I mentioned before, Cochrane, they provide a lot of guidance. They have their own handbook for conducting systematic reviews. Theirs is the methodological expectations for Cochrane intervention reviews, or MESIR. The National Academies, or formerly Institute of Medicine, also has a handbook. JBI, the Joanna Briggs Institute, they have the Manual for Evidence Syntheses, and they have a really great resource because they will give you guidance for different types of systematic reviews, right? Maybe not everything's an intervention review. Maybe you're doing a risk etiology review, maybe a diagnosis review. So a JBI does provide some additional guidance for that. They also provide guidance for scoping reviews. There's also the Center for Reviews and Dissemination. And then PRISMA, which a lot of people always hear about when we talk about systematic reviews. PRISMA is not a guideline for how to conduct a systematic review. It's a guideline for how to report a systematic review. So it tells you what you should be reporting in your write-up, basically. So there are reporting guidelines for systematic reviews, for protocols, how to even report your systematic review search. They have one for scoping reviews and a lot more. So there's a lot of help and guidance out there. So here's an example of the PRISMA checklist. So you can kind of see it's broken down into different parts of like a paper, for example. You have your title, your abstract, your introduction, your methods, and you can see here eligibility criteria, what databases you use, the search strategy, all of these different things. So again, it's not telling you how to conduct one, it's telling you what you should be reporting. And then here on the right column, you have what page number you've reported this on in your write-up. Some journals do require a completed PRISMA checklist. So if you see it says that, that's what they're referring to. And then here's the continuation of that. Now we have the results, the discussion, and then any other information that you should be reporting as part of the systematic review. So as far as non-health systematic review guidelines and standards, there are, like we mentioned earlier, Campbell's great for social sciences. The Epicenter has a guidance for social policy. As far as management, there's the Center for Evidence-Based Management, and they do have guidelines. You know, not everything's going to be called a systematic review. In different disciplines, they may call it like an evidence synthesis, you know, so it depends on the language of that particular discipline. But it's the foundation things are pretty much the same. Okay. For environmental studies, there's ROSES, which is basically like PRISMA, but for environmental research, right? So how to report what you did. And then even for ecology, PRISMA does have a reporting guideline for ecology and evolutionary biology topics or projects. So there are out there, and there's probably a lot more that are available. So we're going to use a published example to highlight different parts of the systematic review process. So here we have one. This one is the experiences of working as early career allied health professionals and doctors in rural and remote environments, a qualitative systematic review. So what guidelines did they use? They tell us in their methods that they use the JBI, or the Joanna Briggs Institute methodology for systematic reviews of qualitative evidence, since they are looking at qualitative research, and that they let us know that they used PRISMA to report what they did. So we wanted to show you a real world example where they're, you know, using the resources that we're mentioning in today's workshop. So now the systematic review process, quick overview. Again, this is a visualization of what happens during the process. Identify the issue and determine the research question, which is really one of the most important parts of the entire thing, because the question then informs everything else. Then you write a plan for the review, which is your protocol. You search for the studies, and then you're sifting through the studies based on the eligibility criteria. Once you pick the studies that have met the criteria, you extract the same data from each one of them. You assess each of them, their quality. You combine it, you synthesize it. If you can, you combine it statistically through a meta-analysis. you discuss and conclude overall findings. And then again, you have your nice little puzzle here that you've put together, and then you disseminate, like I said earlier, through a journal article, or presenting it at a conference, or helping you with your decision making. If you're coming up with a new policy somewhere, maybe it's not disseminated in a published form. So here we have our steps here. We have step 1, which is pre-review. Once you have solidified your question, you come up with your plan or your protocol. Then you start your searching. You screen the articles that you found. You extract data from the ones that you've included. You assess the quality of each one. You synthesize the data, and then you write up the findings. So pre-review, which is the step 1, this is probably one of the most important steps, because this will basically inform everything else. So here's where you're going to assemble your team. Again, you want to make sure you have multidisciplinary expertise. You want to solidify the roles and expectations for that team. You also want to formulate the research question. Is there a gap in the evidence that your systematic review will help fill? Are there enough studies to do a systematic review? Sometimes people have really awesome ideas, but maybe it's something rather new and there just isn't enough to do a systematic review. Maybe a scoping review is better at that point to kind of map out what's actually out there first. Using a research question framework is really helpful, like PICO or PEO or SPICE, right? Depending on your discipline, or your type of question, there's certain different frameworks. And then you want to also search for existing systematic reviews. Has someone already done this? Is someone in the process of doing this, right? Look for any systematic review protocols. If there are existing systematic reviews, should you still do a systematic review? It doesn't mean that you shouldn't, right? Some things that will help kind of justify doing another one, are they older, or do they need an update, or can they be improved upon? Did the one that you find, maybe they didn't do such a comprehensive search, or maybe, they didn't, fully appraise all the studies, or, if there's certain weaknesses there that your team can improve upon, then it justifies doing another systematic review. But if there's one that was well done and it was done, like yesterday, then maybe you need to kind of go back to your question and see what gap can you fill? What's the rationale for doing one? Because it is a long-term project and you should have a good reason for doing it. Then after you have come up with your question, the plan is the second step here. Here on the cartoon, we see how far did you get? And the researcher's like, I've got the conclusions. I just have to write the protocol. That's definitely what you don't want to do, right? You don't want the conclusions to be, biased, right? Based on what you're seeing in the results, because then you've introduced a problem into your project. You want to make sure that the protocol, everything is decided in advance, and then that is what informs the rest of the project. Again, to keep you transparent and to minimize any bias, that you're not making decisions based on what you're seeing, that you've already made the decisions in advance. So developing a protocol, again, this is your plan, blueprint for your entire systematic review project. It should be done before you begin, right? A priori, just like any other study type. And you want to make decisions for the project in advance. So it helps keep your team on track and anticipate all parts of the process. So if you are, if you know which tools or software you're going to use or how you're going to manage data, does anybody on your team need training on any of that software? It also ensures transparency and minimizes potential bias. And we do encourage you to register your protocol because it can help avoid duplication of research efforts. So the protocol includes rationale for the review. Why are you doing the review? How does it fit into the context of what's already known? The review question, the PICO or any other elements of that question well defined. Who is the patient and population problem? What intervention are you considering, or exposure, outcomes? Everything should be clearly and explicitly defined. Your inclusion-exclusion criteria. So here are some common inclusion-exclusion criteria. So again, defining your PICO or each element is going to help you then identify your inclusion exclusion, right? Who are the people that you're interested in, the participants? Is there an age, right? Are you only looking pediatric? Are you looking at adult? Or are you looking at a specific setting, college students? Is it undergrad, graduate, both? So those are things that by you defining all of that in advance, how to develop your inclusion exclusion. If you're looking for certain types of study designs, what outcomes specifically are you looking for? And then you see some other ones here that have an asterisk. So these are the tricky exclusion criteria that some teams usually use. So the date exclusion, you'll see sometimes, oh, we only included studies from the last 10 years. That should be justified. If it doesn't have a good reason, then you should not be limiting by date. So for example, if you're doing something health sciences related and you're looking at a certain drug and it wasn't approved until the year 2000, or, it would make sense to then limit to that particular time. But most of the time, the date filter should not be, used in searching. It shouldn't be unless there's a good reason for it. Geographic location, there should be a rationale as to why maybe you're limiting to a certain geographic location. If you're only limiting to English language, just know that that is potentially introducing publication bias into your search results. Peer review, not everything is peer reviewed. When you're doing a systematic review, you're trying to be comprehensive. So sometimes you want to include unpublished material that may have not gone through a formal peer review process. Also, not every database has a peer review filter. So that one's a little bit more tricky. And then type of publication, sometimes people exclude like review articles or letters or, things like that. And that's something you also have to be careful with. Because maybe a letter or a review article can point you to additional studies. So you have to be careful about those types of criteria that you use to exclude any studies from your results. So in addition to the inclusion exclusion, information sources, what databases are you going to search, your search strategy, your data management plan, how you plan to select your studies and screen them, how you plan to extract data and what data are you going to extract from each study, tools and checklists that are using for risk of bias for each included study, and how data will be synthesized. So all of these things are decided in advance in a protocol. And then how you plan to disseminate this. What journals are you going to submit to if you're going to submit to a journal? So there is guidance for protocols. Cochrane has the MASIR. They have a section about how to develop a protocol. JBI has protocol development guidelines for different types of systematic reviews. And then Prisma has an extension called Prisma P that tells you what should be reported from a systematic review protocol. And then at the bottom here, I have Prospero. Prospero is for health science systematic reviews. It's a registry where people go and register their protocol. So it's a great place to search and see what systematic reviews are in process. There are other options. If it's not a health science systematic review, that you can still publish your protocol. Some people publish them as journal articles. Some people put them on Open Science Framework or OSF. So there are multiple options to make your protocol public so that people are aware. So here's our published example again, right? If we go back to that, they let us know that they did create a protocol and that it was published and that it was also registered in Prospero, right? Which is what I just mentioned. And then here they tell us this up here is a screenshot from Prospero. So this is their protocol right here in the registry. And then this group also published their protocol in a journal. So they basically got two publications from this same systematic review, right? They published the protocol and now they followed that protocol and now published an actual paper, their report on what their findings were. So now that we've talked about what they are, what you should consider, the standards and guidelines, and then what you should do as far as pre-review and protocol, we're going to move into the search. So I'm going to turn it over to Ramses.
Ramses, you're muted.
Oops, sorry. Okay, the search process. Can you guys hear me now?
Yes.
Okay, thank you. Sorry about that. Okay, so the search process. So systematic reviews require a thorough, objective, and reproducible search of a range of sources to identify as many eligible studies as possible. Now, within the next few slides, we're going to go and explain what we mean exactly by thorough, objective, and reproducible. So the reason we do this is a major factor that distinguishes systematic reviews from traditional narrative reviews. So the aim of a systematic review is to identify all relevant studies, published or not, on a given very specific topic. So researching or searching should be based on the principle of comprehensiveness with the widest possible collection of information sources that are considered appropriate for this review. So what do we mean by thorough? We mean we're going to search in multiple databases. We're going to use a wide variety of keywords and text words. We're also going to rely on some of the subject headings that are natural to the to each different databases. And when possible, we're going to use supplementary searching. By objective means that the search terms will include variations in terminology in order to avoid bias in the term selection. And by reproducible, we mean the search must be able to be essentially just plugged in to each of the databases that have been used by the reviewing committee while getting the very similar or exact amount of results. So your searching has to be documented in detail. It must include the database or platform that you use. You will record how the search strategy was executed, and all the searches will be done in the same day, and you will provide that date that the searches were conducted on. So now, research question and eligibility criteria will determine which information sources, aka databases, to search. And it will inform your search strategy, like concepts to search, keywords and synonyms, and subject headings from each database. Now, where to search from? When you doing this kind of search, you have a wide variety of databases that you can use for. You have your core databases like Medline or PubMed. We have Embase, Cochrane Central, Web of Science, and CINAHL. Those are just very general databases, which will be sort of the core for what you would use. There are also subject-specific databases that you can throw in there in the mix, such as PsycInfo, Sports Discus, or International Pharmaceutical Abstracts. There are also regional databases that can be used, such as LILACS, Cielo, or African Index Medicus. And you could also search for gray literature. By gray literature, we mean anything that would not be contained in any of these databases that has valuable information to your research. So you can look into, for example, clinicaltrials.gov, the World Health Organization International Clinical Trials, ProQuest thesis and dissertation. So anywhere, you could also include, statistics, government statistics, just any other valuable information that's not contained on the above databases. Now, I'm showing you this. It's sort of a little bit of a shock factor, a little bit of, whoa, what is this? And just to show you that essentially we're going to build this. So in about 4 or 5 slides, this mess is going to make sense, I promise. So this is a search string. In this case, it's a search string on Embase. And you can see that there's a combination of different terms, and you have all this quotation marks and ands and ors and all this, but eventually this is what your search string for each database will look like. And it looks a little, weird and scary now, but it will make sense in a few slides from now. Now, the steps for the searching steps for a systematic review are as follows. First, you identify the main concepts from your research question. then you harvest all of your search terms out of those, main concepts. You create a search strategy for one database, which is what we did in the previous slide. Then you translate it to the other databases being searched. We'll go into that in the next couple of slides. You run all the searches on the same day. You will export your citations, and then you will remove your duplicates. After you've done that, then you're ready for the screening step. But this is how you do, your searches. Now, always keep notes and documents of all steps in the process as they might be required. Now, let's get started with identifying the key concepts from each research question. There's a few. Hello?
Yeah, we're here. I think your PowerPoint closed. I think you just need to reopen PowerPoint.
Yep, on its own. Sorry. You guys saw that,
Yep.
right? I didn't do anything. It just.
It just crashed, no worries.
It crashed. I think I'm here.
Yep,
Yeah, I'm
there you
here.
go.
Slideshow. The joys of live performance. Okay, so you have your acronyms that you use for the different just recent ways in which to identify your concepts. So you have your PICO, which is one of the more popular ones, or the most popular one, stands for population or problem or patient. Intervention, comparison or control and outcome. Another very popular one is PO, which has with the studies that don't have a control element to it. So it would just be population, intervention, and outcome. Sometimes it's population exposure or an outcome. And in the social sciences, you have the SPICE model, which stands for setting, perspective, intervention, comparison, and evaluation. Now we're going to have an example here of systematic review. So let's go pick out our main concepts. The question is, what is the impact of diet and physical activity on the gut microbiome for the treatment of overweight and obesity in children and adolescents? So we have our population. In this case, we have overweight children and adolescents. In this case, we're going to separate them because they're independent concepts. So we have the population is split into two. Our intervention is diet and exercise, and the outcome is the effect on the gut microbiome. So that's how you split it. In this case, it's a PIO or PO with we're going to split the population into two since they are independent concepts. Now, how to identify your search terms? You're going to create two separate lists of each one of those concepts to become your search terms. You'll have natural language, which are your own keywords, something that you can find, you're hoping to find in the title, abstract, or, author keywords in the, within the article. And then you have control vocabulary, which are proprietary to each database. So control vocabulary are, subject headings or medical subject terms that are designed or assigned by each database as the search terms for that particular concept that you're looking for. So why do we do this? Why we split it into both natural and control terms? Well, let me show you. For example, this is the abstract and title of an article that we use for that same that was found while using both control language and natural language. And if you can see here, under major subjects, we found gut microbiota, and these are the terms that came from the control language of the database. And if we look in the abstract, all of those terms that are highlighted, those are terms that came from the natural language that I use. So by using both the control language and the natural language to search, I made sure that I give myself the best possible chance to draw the most amount of relevant results that I can. So that's what we use both control and natural language. Now, as far as finding terms for natural language, you could just, repeat any of the control language that you find. You could use synonyms, different spelling variations like plural and single variations, acronyms, so you spell and also spell it out. For example, you will look for PTSD and also post-traumatic stress disorder. So make sure anything that is well known by an acronym, you also use spelled out, and then you could use narrower and broader terms. Now, as a tip, you could always find 3 to 5 studies that meet your inclusion criteria and use them to gather terms, from the title, from the abstract, or from the author keyword. So that really, really helps. And it helps identify additional terms, by searching, doing background information. You could also use an AI tool, or sometimes even, ChatGPT to generate different synonyms. Now, as far as finding control language, each database has its own specific section where it contains all of its control language. So, for example, Embase, you will go to Emtree. CINAHL, you could go to CINAHL subject headings. PsycInfo and ERIC have thesaurus. Medline, for example, Ovid, it gives you an option to check the box for mapping terms to subject headings. And on PubMed, of course, we have the mesh database. So what we're going to do now is Joanna is going to take over, and she's going to show us how to find the control language on several different databases.
Sure will do. So I'm going to share my screen. Thank you, Ramses. And I will share. There you go. So we are going to demo some of the steps that Ramses has already described. And to do so, we have to start from having that search term. So from the search term that Ramses already mentioned, imagine that you have to start thinking about it in the way that you could extract more information and get more articles to support your topic, your research, and to make your systematic review more comprehensive. So you will start by thinking or highlighting or finding a way to extracting those keywords such as diet, physical activity, gut microbiome, overweight, obesity, and children and adolescents, because it's the population that we're working with. We could do this with many other terms related to the search. For example, the impact, because you do not want all the articles in the universe related to these topics combined, but only the ones that have to do with studying the impact or the influence of that process. So, but just for the purpose of this demo, we are going to try to simplify it. And when you put your keywords in this order, you can understand that at the beginning, you're just starting to brainstorm and with your natural language. So it is okay to just start like typing, for example, diet out of the top of your head, or dietary, or fasting. But your search and your initial approximation to the topic does not have to be complete from the beginning. It is a process that you can enrich using many vocabulary, control vocabularies, online resources, as Frances was mentioning. But the databases itself can help you with that. So for example, when you decide which database you're going to use, from the list of main databases that we typically recommend for general health sciences or for many different type of systematic reviews, you can visit the A to Z database list. if you're starting from the Green Library, or if you are a medical library user, sorry for the scrolling, there is a link to the medical library and a link to the medical library databases that you can use in their website. So whichever the website you start from, just make sure that you use the library databases and you start from here so that you can guarantee more access to the full text and for the many advantages of using these resources. When you filter our list to health sciences, that helps enormously to get a smaller portion. So if we do health sciences only, you end up with 135 databases. And out of this list, we have already highlighted CINAHL Ultimate. So I'll demonstrate how, when you start this search using CINAHL Ultimate, and you can start adding your search terms. But as soon as you start typing diet, you'll notice how the database will be so smart. Like this is the artificial intelligence, like the automatically generated terms that are useful and are on topic. So you could get some useful terms and add them and enrich them as you're typing. So for diet, you now have diet or nutrition or food habit or eating habit or lifestyle or food. Some of them may not be a good fit for your search. So it is up to you to include or exclude. And this is something that is going to enrich your list of terms. So you can start building that list of terms based on what you're finding in the databases. Of course, this is only natural language. This is not a controlled vocabulary yet. This is only the common words that are more repeatedly used in searches. We have also physical activity, right? Or exercise or fitness or physical exercise. These are all good. So you can see how this exercise of just adding terms here generates good alternatives for you to find articles on how the diet or nutrition. In this case, our search was diet and nutrition or these terms. So I will combine them using OR because for the purpose of this search, right, it is the same to compare the use of food habits or physical activity in the next step, which is in the microbiota, the microbiome. So if I type gut microbiota or microbiome, I'll get good recommendations. And we can go on with the process of typing overweight or obesity or obese. And for now, we are not applying any other limiters, right? Because we just want to explore and see how our comprehensive list of results is so rich in information that can improve the quality and the thoroughness of our search. Why? Because the subjects that the database is including in the record for the articles are a source of information very valuable because these are terminology, these are part of that controlled vocabulary that the database already has assigned to these articles. So getting information from here, it's super useful because now you know that obesity, it's a subject, physical activity evaluation is a subject, obesity in old age, etc. However, if you want to explore a little bit more and have the definite term for how to use it, you could go to the CINAHL subject headings. Before getting there, I want to show you a useful tool that you can also explore, which is the major heading subject. That when you expand it, you can go to show more and get a lot of information more related to my topic. So if, for example, I was interested in obesity and in seeing what type of subjects are associated to obesity, I can click on names, get it alphabetically arranged, and under the letter O, check if there is any other related term. For in this one, it's only obesity, but I'll add that. And I can also include a subsection of the obesity articles, which are the pediatric obesity ones. And because my population is child and adolescent, this one applies. So this is only one example of how you can use this info and come back to your list of terms. And now you know that CINAHL has a subject, which is obesity, and another one that is pediatric obesity. Right? The thing with the databases is that each one of them, it's slightly different and they have different vendors. So the control vocabulary and the platform itself changes. And you have to keep the same approximation strategy from database to database in order for you to identify the major headings, the subject terms for each one of these resources. I'll quickly show you if we do this in Medline. The process will lead you to some similar articles, some different, because it's a different product, so some journals may overlap. But we will here have, and I have it already run so that we don't have to retype it. Let me just bring it to this screen. Okay, here. So if we run the same search in Medline and we use a similar strategy, and I'm trying to accommodate the window in my small laptop screen. Sorry about that. Okay. So once you're in a list of results here, you can use similar strategies of having already your search run and exploring the abstracts, the details for each one of the articles. However, some of the articles may not have a very obvious subject identified in here in Medline. So you will find that some of the article records could somehow do something similar, like take you to, oops, this. I'm going to add diet, my screen, and physical activity. And got my microbiome. So if the database is not giving exactly the search, the subject terms for associated to my search, you can also use the subject tool on the left-hand column and learn a lot about what are the most prevalent subjects associated to my search results. So you start with your natural language terminology, and through the search, you can isolate gastrointestinal microbiome as a very powerful tool for you to recover articles, not only that talk about microbiome if I type it as a keyword, but that gastrointestinal microbiome on its own will pull all the articles about this. So this is another term that you can copy and add to your list of terms. And that's how you start like building it little by little, adding blocks and making sure that you are as comprehensive as possible. Medline also has a thesaurus that allows you to search the mesh thesaurus, which is the medical terminology thesaurus for the National Library of Medicine. So if from here, if I am still in doubt and I would like to find out how to treat a topic like diet, I could still type it here and check how is it treated. If it's on its own, here it will give me the definition. Here it will give me a breakdown of subtopics that I could apply. Maybe I'm only interested in the articles about diet, but only in the ones related to the history or the ethics or the economics aspects of it, and so on and so forth. So there is a lot of richness on what you can do here. Notice how, for example, this one has a diet habits term that you could also use. And they even have like feeding behavior, and they are recommending feeding behavior to be used instead of diet habit. It's really up to the research team to determine which term applies and which term is better to include or not in your search. So that's a little bit of the live section that we had programmed. And with that, I'm going to stop sharing and I'm going to turn it over back to Ramses. Thank you. Oh, do you have any questions with this segment before we move? Okay, sounds like no. So I'll stop my share. Go ahead, Francis.
All right, thank you, Joanna. So as you can see, for example, just from using the concept of gut microbiome, we have all these natural keywords that you can find. And then you'll see that each one of the databases, CINAHL, Embase, and Medline will have their own terms and their own control language. So you have to use all of them together, okay? Each one of the search has to combine all of them. And one thing that you should always do is to make sure that the control language from each database is also included into your keywords or natural language, okay? Okay, so how do we combine them? We use and, or not, Boolean characters. So and, it tells the database to retrieve items with all your search terms in it, and it's used to combine separate or independent concept, and normally tends to narrows your search. Okay, so we would use independent concepts such as gut microbiome and exercise, or tells the database to retrieve items with either terms. It's used to combine similar concepts or keywords as synonyms, and it broadens your search. For example, you would use children or adolescents. Not is usually not recommended because it tells the database to exclude items, with a specific term, and it's used to, exclude keywords, and it narrows your search. So it's not usually recommended that you use not. Now, remember, this is the first scary search screen that we looked at. Now, hopefully it makes a little more sense. See, for example, for Embase, here at the top, you have the natural, I'm sorry, the control language, followed by the natural language of each one of your concepts, okay? So you have your 4 different concepts here, and then in the blue highlighted would be the control language for each one of the databases, combined with, in the yellow, with the natural language that you have come up with. Okay, so hopefully now it makes a little more sense than it did, I don't know, about 15 minutes ago. Okay, this is what this would look like in Medline, Ovid. Oh no, I'm sorry, this is an Embase. The same search, this is what it would look like. You would run all your searches and then combine the main concepts. And this is, what the outlook will look like. In CINAHL, for example, one concept will look like this. This is how you translate it. Now that we've done it at Embase, the concept of translating it is making sure that it makes sense in each database when you input it, okay? So it will look a little bit different. For example, in CINAHL, this concept looks a little different than Embase. You know, Embase is not usually too crazy about double quotation marks like CINAHL does. So, you know, this is what we mean by translating it. And here we're looking in, for example, or AB is abstract, AB is abstract. Here it's title, so we're looking for title and abstract, while in Embase, it looks for title, abstract, and author keywords. So title, abstract, and author keywords right over here. So this is what we mean by translating it. You're still using the same search terms. It just looks a little bit different from database to database. So this is what it looks like in Scopus. So that's what we mean by translating it. Now, once you have your results, you move into the exporting phase of it. So always export in RIS file format. That is, .irs is the, generally acknowledged file format for citations. So export process will vary from one database to another. You may want to export to a citation manager first, such as Zotero or EndNote, or sometimes to a screening program like Covidence. The good thing about going to like Zotero or EndNote is that they have very strong deduplication software. So you must always remove all duplicates. However, even after you let either program, either Covidence, Zotero, or EndNote, get rid of your duplicates, you should still go one by hand to make sure that all the duplicates have indeed been removed. Now, always document the search process. So this is essential to report the search process so your methods are transparent and reproducible. Make sure to document all the databases that you search, as well any of additional methods of searching, such as hand searching, snowballing, etc. The date that the searches were ran, it should all be done on the same day. The number of results for each search, the search strategy for each database, which is the previous slides that we were looking at, and also describe the process for removing duplicates in documents and how many duplicates were removed. Okay, so the guidance from Prisma for reporting search here, it could take you to that, and then we've already looked at it. And you see when you follow the search strategies, these are the guidelines to follow for documenting your search and conducting the search. So it's right there on the Prisma guidelines. See, updates, report the methods for update the search, indicate whether published search fields were used. Everything is in there for you. Now, here's a published example that we were using before, and this is how you describe in the paper your research strategy. See, it has a date. So, for example, systematic review was conducting using. You have your databases there, and then the searches were conducted between so you have your searches, the search dates, and the key search terms were related to early career, allied health sciences. Now, table 1 outlines the medical search terms. These were adapted for the additional databases, individual styles and phrasing requirements. So right there, you are documenting your translations. And for example, from this for this published example, you see table 1, it's the actual, table that was used, to run the searches and the translation for this particular database. So that should always be in the appendix. Send all of your search strings also along with the review itself, with the paper. Here's the published example. For example, the results of all searches were uploaded onto a Covidence software. So you're letting them know what's happening every step of the way. And of course, this is your Prisma table, which Covidence actually supplies, and it identifies all the the searches that were produced from the database, the records removed before screening, records screened by title and abstract. So all the exclusion, it has the exclusion and inclusion criteria. Here, you must also send that. So everything will be documented just in a very detailed way. Now, screening process. All results should be screened by at least 2 people independently. This is one of the many reasons that systematic reviews are a team effort. You need a team of at least 4 or 5 people because it just minimizes bias. So that should be reviewed independently by at least 2 people. A third person can serve as a tiebreaker for any disagreements. And remember, reviewers are evaluating whether a study meets the specified inclusion criteria, which was decided at the very beginning of the process during the protocol. Now, step 1, you examine the titles and abstracts for all the search results. If the study meets the inclusion criteria, it goes on to the next round, which is the full text screening. And if it does not meet the criteria, boom, it is excluded. But you also must document the reason why. Step 2, retrieve the full text for potentially relevant studies. They should be still independently reviewed by at least 2 team members, and you should make the final decisions on the study inclusion. For any excluded studies, also document the reasons why it did not make it past the second step of the screening process. Now, as far as selecting study tools for screening, you could use Covidence, which is something that is provided by FIU free of charge. It works very, very well. You could use RAND, which is also there's a free and a paid version, or you could use Abstracker. Now we're gonna look into Covidence a little bit because I tend to recommend it, A, because it's very good, and B, because it's free, provided by us. So we'll take a quick look at it. This is what the main interface of Covidence looks like once you have imported your search results into the title and abstract the screening phase. So you have all the screens here, and then this will be your second, the full text review once it makes it past the title and abstract screening. Now, the title and abstract screening, when you go into it, this is what comes up, just your title, and as it says, the abstract. You look at the abstract, and independently, 2 people decide whether or not it gets a no, a maybe, or a yes. Remember, this will be done independently. So if there's a disagreement, a third person would come in and be the tiebreaker. You could add your inclusion and exclusion criteria here. You could highlight, there's a lot that you could do here. And of course, if there's a conflict, it will appear here. And then the third person, the tiebreaker, can, break the tie. Now, once you've done that, it goes to the full text review. And the cool thing is, each one of the articles that has made it to the next, to this step, you can click on the DOI and it will actually open the full text review. And it still has the same, criteria, has, include, exclude. You can add, any notes to it. And of course, any conflicts, any disagreements will automatically go into the resolve conflicts folder, and then the tie can be broken. Prisma also automatically, once if you document all of the reasons why each one of the studies was excluded, then it will automatically populate the Prisma chart flow, which you can just print or add into your into the appendix for your documentation and send along. So it's really comes in handy. Now, of course, all of this will be documented, and you can see here from the published example that we have, duplicates were removed and the titles and abstract were screened by, AD and SG, the authors. Potentially relevant studies were retrieved and full assessed against inclusion criteria by all authors. So it goes on to talk a little bit about the data extraction and the qualitative appraisal, but as far as the screening goes, this is just simply how you would document it. And as I was showing before, this is what the from the published example, what their Prisma flowchart looks like. This is everything that was identified, screened by title, screened by full documents removed, and the reason why the documents that were excluded were indeed excluded. All right, so now we come to the final, extracting data process of it. So I'll turn it back to Daisy.
Hey, one second, sorry. Okay, so here we are. And I just wanted to mention briefly too that Confidence, when you're doing the screening, you can add your inclusion exclusion criteria from your protocol in Confidence, so that when someone is screening, they'll have that criteria right in front of them, and that'll help them decide yes or no. So it's a really, really wonderful tool to help you streamline the whole process. And it helps with this next part, which is extracting the data. So once you've done your searches, you've retrieved all the results, you've screened them, and now you are left with, let's say, what was the published example? What were they left with? 30 studies, let's say. Now these 30 studies, you have to extract the data from each of those studies. So when you develop the protocol, the team decides what data you should be collecting. The research question obviously is going to inform this. It's helpful to use a form or a spreadsheet to help you collect the information. And then items to consider for data collection. So from each study, you want to collect the identification information. So that's the citation information, like the author, the publication date, confirm the eligibility for each study. Why did each study make the cut, basically? What was the study methods or design for that study? Who were the participants? How many? What was the setting? The intervention, the comparison to that intervention, if it's applicable, or the exposure. What were the measured outcomes that they were looking at that are relevant to your research question, and then documenting the results. So like I mentioned earlier, Confidence can help streamline the data extraction for each of the included studies. They have a tool for that too, in addition to the screening. So here's our published example again. They tell us that they use the JBI, or the Joanna Briggs Institute Qualitative Data Extraction Tool. So when we look at that, this is what that tool looks like. It's basically a worksheet. So our authors in this published example, they had 30 of these to do, right? Because they had 30 studies that made the final cut. And they basically extracted the same data from each of the studies. So this keeps it consistent from one study to the other. It also helps to have 2 people do this for each study, so that there's, minimal bias, and to also help with any, prevent any errors. So if you were the reviewer, you would put your name, the date, the author of that particular article, the year, and then you would fill in all of this information. What was the methodology, the study design, phenomena of interest, the setting, etc. So then they create this table based on what they extracted using that form or that worksheet, right? So they have the author information in the first column. If it was medicine, like or allied health professionals, what country the study took place in, the population, right? They have the amount of participants, and they have the description of the participants, the study design, the methodology. And then on the right, they have the phenomena of interest that they were looking at in that particular study. So once you extract the data, you're going to have this really nice table. And most systematic reviews, they should have a table like this in the report. So once you've extracted the data, the next step is to assess the quality of each of those studies. So our published example, they had 30. So for those 30 studies, they have to assess the quality of that particular study. So quality of included studies, this includes risk of bias, quality assessment, critical appraisal, right? These are all usually interchangeable. It helps establish transparency of evidence synthesis results. So, if you're making any type of conclusions in the systematic review, is it based on strong evidence, or does the studies you included, are some of them good? Are some of them highly biased? Are some of them low risk of bias? So the reader should know that, and that's through this critical appraisal process. The goal of assessment is to identify and report biases for each included study. And the quality assessment of any study is likely to consider the following. So appropriateness of the study design to that research objective or question, risk of bias in that study, and then other issues related to study quality, choice of outcome measure, does it make sense? Any statistical issues? Was there an issue with reporting, right? Did they report everything adequately? The quality of the intervention itself and its generalizability to other similar populations. So there are like all these other things. There's tools and checklists to help out. So there are checklists to help assess the quality or the risk of bias for specific study designs. So depending on the study design that is that particular study that you've included, you would find the checklist appropriate to help you assess it. So here are a few. Cochrane has one for risk of bias for randomized control trials. The Critical Appraisal Skills Program, or CASP, worksheets are awesome. They have for several different study types. JBI, or the Janum Briggs Institute, also has critical appraisal tools. For case control or cohort studies, right, qualitative observational studies, there's the Newcastle Ottawa scale. And then at the bottom, we have here the grading of recommendations, assessment, development, and evaluation, or GRADE, which is you looking at the overall strength, right, of all the included studies in your systematic review. So these are just a few. There are many more. And there's probably more out there related to studies in other disciplines as well. So here's our published example. Again, they let us know that for their quality appraisal, they use the JBI Critical Appraisal Checklist for qualitative research. So this is what that checklist looks like. And again, they would have to do this for 30 studies. So they're trying to find out, you know, the first question, is there congruity between the stated philosophical perspective and the research methodology? Yes, no, right? So they're answering these exact same questions for all 30. And then here's a summary of that quality or critical appraisal, right? Where for the first question, 25 of the studies, yes, they did meet this criteria. One of them didn't, and 4 of them were unclear. You know, for number 8, are participants and their voices adequately represented? All 30 said yes. So that's good. So they're able to summarize what the quality of all the studies look like based on this, you know, consistent worksheet checklist that they used or criteria that they used. So once you've screened and then you have extracted the data, and now you've assessed its quality, now you kind of have to put all this together and synthesize it. So when you're summarizing, you're going to have a descriptive summary of all the included studies. So that's that table that I mentioned. And this would include describing the characteristics for each study, and then the narrative synthesis, right, which is the report. And this is the analysis of the relationships within and between the studies that you've included, and then the overall assessment of the robustness of the evidence that you found. And then if possible, then you could try to do a quantitative synthesis or the meta-analysis if the studies are alike enough to each other that they can be statistically combined, again, which is not always possible. So here's our published example again. In their synthesis section, they found 30 papers. They found 331 findings across 23 categories, right? So they used some type of coding to kind of code the results that they found to help them synthesize this. And then the categories were integrated into 3 synthesized findings. So all the findings were kind of synthesized into these 3 main themes. And then within the different categories for allied health and for medicine. So again, that's what they used in order to kind of, everything that they found in those 30 studies, they kind of, you know, filtered it into like these main 3 findings. And this is a qualitative systematic review. A quantitative one may look a little bit different from that. So then finally, you write up the findings, right? What you found and what you did, right? We've been really stressing that here. So your systematic review report, you want to use the PRISMA reporting guidance, right? What is it that you need to report about the entire process and about the results? If you're submitting to a journal, make sure to verify that they do accept systematic reviews and what their requirements are. This should not be done when you, at this point of the process. This actually should be done in your protocol, right? In the dissemination part, find or identify a few journals that you plan to submit to. Make sure that you confirm they accept systematic reviews and what their requirements are. And if you need help with that, that's why we're here, the librarians, to help you find the right place to disseminate your work. So here's a suggested structure of a systematic review report, where you have your title and your abstract. And then in the main text, you have your introduction that kind of sets the stage for your systematic review. What's the question? What are the methods, right? How did you find the studies? Where did you search? How did you screen? What inclusion exclusion criteria did you use? Where did you screen if you use something like Covidence? How did you extract the data? How did you assess its quality? And how did you synthesize it? So basically, this is the how. And then this is the what you found, right? So what were the details of those included, excluded studies, the findings of the review in general, any secondary analyses, your discussion or interpretation of the results, and then the conclusions, right? Which is, why does this all matter? What are the implications for practice or future research? So here's our published example again, and they disseminated their work in this journal in BMC Health Services Research as a journal article, right? And we've seen bits and pieces of their paper and how they've kind of met every criteria of the systematic review process. A quick note that systematic reviews, just because there is one, doesn't mean that it's good or well done. Systematic reviews, just like individual studies, should also be critically appraised too. So if you are looking at systematic reviews, there are checklists out there to help you figure out if the systematic review was done properly. As you've seen in today's talk, there's a lot of moving parts, a lot of requirements. So they have to follow a lot of things for it to be right. And these checklists help you kind of figure out if they did what they had to do. So here we have the ROBUS tool from Cochrane. I'll just point out the one here at the bottom about the identification and selection of studies. When you're looking at a systematic review, you want to see, did the search include an appropriate range of databases, right? Was it comprehensive? Did it include unpublished reports? Were the terms and structure of the search strategy likely to retrieve as many eligible studies? Were restrictions based on date, publication format, or language appropriate? I talked about this earlier. Should you be adding these filters or limiters to your search when it's not really necessary? So that's a nice way to kind of make sure that the systematic review you're reading has been done properly. So some takeaways and recap as we conclude here. Systematic reviews are research studies, right? It goes beyond just a lit review. Their goal is to identify all the studies that answer a specific research question and combine those studies. Systematic reviews are one of the highest levels of evidence. So this is important to practitioners, decision makers, to public health. Just one of many types of evidence syntheses. As we mentioned earlier, you don't always have to try to do a systematic review. There are many other options out there that may be a better fit for your research question and also for the availability of time, or if you have a team or don't have a team. It is a long-term project that does require time and a team, as I just mentioned. Make sure that you have a protocol or a plan and that you complete this before you start working on a systematic review to help you make all those decisions in advance. There are several guidelines and standards that help you conduct and report what you did. And this is our contact information. We understand it's a lot of, like I said, moving parts. So us, the librarians, we're here and happy to help you, especially with the search. You saw it's very involved, searching multiple databases, translating, identifying keywords, controlled vocabulary. So we are here and happy to help. So Ramses or Joanna, did you want to add anything else as we wrap up?
No.
No, just, reach out. Let us know if you have any questions.
Yes. And just one more plug. Again, this is part of the WorkSmart Library Workshop. So if you remember, Ramses mentioned about exporting your results to a citation manager. We're presenting on 3 different options in the next couple of weeks. That's RefWorks, EndNote, and Zotero. Where should I publish my research also can be relevant to this. And definitely the research retreat for upper division and graduate students, getting those searching skills can really help. in understanding the search process for a systematic review. So thank you for joining us. Have a great day.
Bye.